So what we're looking at is linear and nonlinear equations today, and there's different methods that we can use to solve them. And you've gone over, and especially in Algebra 1, Algebra 2, we talked about these. More in Algebra 1 a little bit, we briefly discussed them in Algebra 2, is graphing, substitution, and elimination. And when we talk about systems of equations, substitution, we're trying to find whatever value of x and y will make both equations, all the equations, true. Because if we can find an x and y value that will make the equations true, that is the solution to the equation. Most problems have involved either a function of one variable or a single equation, two variables. However, many problems in science, business, and engineering involve two or more equations and two or more variables. Systems of equations. So we have this here, and we're trying to find a value of x and y that will make both of these equations true in order to pair that satisfies each equation. And we find that we call it the solution. So for instance, 2, 1 is the solution for this system. And if we were to check it, we plug 2, 1 in each equation. 2 times 2 is 4, plus 1 is 5. 6 minus 2 is 4. We get a true statement. And if we get a true statement in both equations, then it is a solution. And that's what we're looking for. Now the first method of this is substitution. Solve one equation for one variable, substitute it in, and then solve for the other variable. So we look at an equation like this here, x plus y equals 4 and x minus y equals 2. We want to solve one of these equations for a variable, and it really doesn't matter which one we do or choose. So I'll just take the top one. X plus y is equal to 4. Now, do we want to solve this for x or solve it for y? X. It really doesn't matter because we'll end up solving for the other variable in the end. Because if I subtract y from both sides, well, those would cancel. I'm trying to solve it for x. Trying to get x by itself is equal to, I'll just leave it as 4 minus y. And we're trying to solve it so that we have x equals everything else, or y equals everything else. And once we get that, because this here is the value, x is equal to this. This is what x equals, and so what we can do is we can bring it over here and plug it in because we want the x values to be the same. So if they're the same, the value of this x and the value of this x are the, so this x is also equal to 4 minus, so I can plug that in and have 4 minus y equals 2. Now here, negative y minus y is negative 2y, plus 4 is equal to 2. We're going to solve for y by subtracting 4 from both sides, which gives us negative 2y equals, so y is equal to, right, the negative and negative would give us a, now we can come back up here, because x is equal to 4 minus y, well we know y is, so 4 minus 1 is, so the solution for this here is 3, 1. So if we look at this here, hey, well, they did the opposite. They solved for y first instead of x. That's fine. Because they got y equals 4 minus x, input it into the other equation. So they have x minus 4 minus x equals 2. Distribute the negative. They added 4 divided by 2 and got x is equal to 3. Well, that's what we got, yes? And when they plugged it back into the equation, slow down a little bit, they got 1.31, which we got also. Now they can check it. We can check it, plug it back in. 3 plus 1 is 4. 3 minus 1 is 2. So it satisfies both equations. This works. Any other questions on this here? And that's what we've got to do for substitution. Or back substitution implies that you work backwards. First you solve for one of the variables, and then you go back and find the other. And that's it. That's substitution. We're solving for 1 and plugging it back in. Nonlinear systems of equations. The equation example 1 is linear because there's no exponents. It's just straight lines. Now we're going to solve this here. This is considered nonlinear because 3x squared minus 4x, that is a quadratic. Well, we can solve this other equation. I would stick with solving this one, not the linear one. 2x minus y equals -1. Well, we need to solve this for the value of y. I would solve it for y. Because, well, if I solve it for x, I'm going to have to plug into x squared and for x. That's going to make it a little bit harder. Well, not harder. We're just going to have to deal with some exponents, multiplying things together. Now, if I wanted to solve this for y, what would I need to do first? Yes. I like putting a variable out front. That's just me. Negative y equals -2x plus 1. Why? Yes. So we can multiply it all by -1. We can divide everything by -1. Yep. Y is equal to? Yes. Now we have this equation over here. And what we can do is we can take this, because this is what y equals, and plug it in for y, which would give us 3x squared plus 4x minus 2x minus 1 equals 7. So we have this here. Now we can, it's going to be a little bit easier if we distribute this negative through. We have to apply that negative to everything inside the parentheses. It would give us -2x plus 1 equals, yes, let's combine like terms. That's going to make it a little bit easier. 4x minus 2x is? Mm-hmm. Since 6 is negative, our signs are opposite, positive and negative. Factors of 3x are 3x and right? Because 3 and 3 can't go together. And 1 and, or because 6 would be over here, and that'd give us a big number. 2 and 3, 3 times 3, nope. Yep. Negative b. Yeah, because as long as we have everything, our sign's correct. Yep. 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 Mm-hmm. Yep. So negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Well, that would be 6. Because 2 squared is 4. 4 times 3 is 12. Times 6 is 72. 76. All over 6. Well, -2 and 2 squared are 19 and 6. I'll have a greatest common factor of 2. So I get -1 plus or minus the square root of 19 all over 3. Yes. Simplified the top two, but for some reason did not simplify the bottom. So we get this here. Well, we found the value of x. Now we need to find the value of y. This is where it gets a little bit tricky. Because we have to do 2 times negative 1 plus, let's do each one individually. 1 plus the square root of 19, 3. Now you can type this in a calculator. It might be a little much for the TI-30XS. Because the graphing calculator will just straight up give you a decimal. Because if we multiply it through, we get negative 2 plus 2 square root of 19 over 3 minus 1. And if we subtract the 1, we should get negative 5 plus 2 square root of 19 all over 3. Yeah, the graphing calculator is going to give you a decimal. It won't. And we do the same thing here. 2 minus 2 square root 19 minus 1, which would be negative 5. And we get this video in a minute once we get done with this. So, no, you're good. Because when we look at this here, we solve for the value of y first. Yes? Well, to solve for the value of y first, we would subtract 2x. And we can multiply everything by. It'll make sense here in a minute. So we get y equals 2x plus 1. Now we have the other equation. Because we have y equals, well, this value of y is going to be the same as this value of y, so we can plug it back in. And we get 3x squared plus 4x minus 2x plus 1 is equal to 7. Now we can distribute that negative, which would give us negative 2x minus 1 is equal to 7. Now we can combine like terms, like to make it a little bit easier to work with. 4x minus 2x would be plus 2x. Well, we can also subtract 7, do 2 steps in one. Minus 8 is equal to 0. Now this is factorable. Because we have 3x and x, we would have minus and plus. Factors of 8. Other way around, it'd be 4 and 2. So it should be 3x minus 4 times x plus 2. At this point here, we can solve both of these. 3x minus 4 is equal to 0, and x plus 2 is equal to. So x is equal to thirds. And for this one here, x is equal to negative 2. Now y is equal to 2x plus 1. So we can plug each one of these in. So we'd have y is equal to 2 times 4 thirds plus 1. And y is equal to 2 times negative 2 plus 1. So for this here, 2 times 4 thirds would give us 8 thirds, which would be, because that's the same, 8 thirds, which is 2 and 2 thirds, plus 1 is 3 and 2 thirds. That should be about 3 and 2 thirds. 3.6 repeated, I think is the other way it should look. What did you get?
11 over 3.
11 over 3. And if you approximate that as a decimal?
3.6 continuously, except for 1.7 at the end.
Yep, so we'll have 11 over 3, which makes this point here be 4/3, comma, 11/3. Now over here, we already have the x value of -2. Well, this would be -4 plus 1, which gives us... So these here would be our solutions. This is what we should have. So, and they're going to do a similar thing here. They're going to start off exactly like we did, simplify, and getting this here. Now we plug them both in to get our two answers. Apparently not. I'm going to move on. It said no. So we can look at some more of these here, some more of these substitution with non-linear equations. Especially with that. They'll come up a little bit here and there, but it's going to be a little different. I don't think so, but they might show up. Okay, we're going to look at this one here. Okay. So, we want to solve one of these two equations for a variable. Why don't we solve this one here for y? So what do we need to do to solve it for y? Add x. So we get y is equal to x plus yes. So we get x squared plus x plus 4 is equal to 3. X squared plus x plus 1 is equal to, well, we can't factor this. Yep, so we have negative b plus or minus the square root of b squared minus 4ac all over 2 times a. Negative 1 plus or minus. Well, what's the issue with negative 3? Almost. We can pull out something.
You don't, it's a...
Well, this has complex solutions, yes? Because our imaginary numbers are complex. Right. So that means this here is... There's no solution. Because if we end up getting imaginary complex terms, it means it doesn't intersect, it doesn't cross. We have no real solutions that work for this. Does that make sense? Do you have that sheet in front of you? Let's look at this one here.
Yeah, I noticed there I had notes.
Okay. So we'll look at this one here. The first one made a little bit of sense. This one here, this time we have x squared and y squared.
No.
Which one?
I want to do the one on the left first.
I agree. I concur with that. We would solve the one on the left for a variable. Which one do we want to solve for, x or y?
I guess.
I would solve for y, because if we try to solve for x, at one point I'm going to have to divide everything by 2, so we'll have to deal with fractions. Because 1/2 isn't going to be bad with the y, but we'd also be dealing with 3/2. Not as nice. Subtract 2x from both sides. Right? Because that would give us negative y equals negative 2x minus 3, but with our multiplication of negative 1, turns everything positive.
Go over there. Where?
Exactly. We're going to bring this over here, which gives us 2x squared plus 4x minus 2x plus 3 squared is equal to 0. And again, when we square it, we're not just squaring the first term and second term. We're actually doing 2x minus 3 times 2x minus 3. Now, some of the ways I look at it, especially with this here, you can rewrite it as 2x plus 3 and 2x plus 3 and multiply it that way. But I know I'm going to do 2x times 2x. It's got to multiply by itself, which would give us 4 squared. Then we're going to do 2x times 3, which would be plus 3 times 2x is 6x, and 3 squared would give me 9. It's almost the first and second get multiplied by themselves, and then we've got to go both ways. All right. Because if we look at it, and I'm going to just write this on the whiteboard, because we'd have 2x times 2x, 2x times 3, 3 times 2x, and 3 times 3. And if we kind of keep that straight in our head, we can just do the multiplication out. First times itself, first times second, second times first, second by itself.
First and negative.
Yes. 2x squared plus 4x, we're going to do some multiple steps. That'd be negative 4x squared. Well, 6x plus 6x is?
18x. Or 12x. I don't know, but I'm good.
Minus 12x minus 9. Because 6 and 6 gives us 12, but then we've got to change it from positive to negative.
I'm having a rough day.
Now, 2x squared minus 4x squared would be negative 2x squared. We took care of those. 4x minus 12x would be minus 8. You're good. Eventually, we're going to get there. Now, one of the nice things about this here is we can divide everything by a negative. And the reason I do that is I want to get that x squared term to be positive. Because if this factors,
If everything's positive.
yep, so this here, even when we do this, it won't factor. Because the only factors of 9 are 1 and 9 and 3 and 3. Well, 2 times 3 is 6, plus 3 is 9.
Kept running into the light. Too high.
Negative b plus or minus the square root of b squared minus 4 times a times c all over 4.
Yeah.
8 squared 64. 4 times 2 is 8. 9 times 8 is 72. 64 minus 72
So it's going to be imaginary. So
is negative 8. So this is no solution. There is no way that these two will intersect. Okay. Let's do the other one on that sheet. What was it? This one's a lot nicer for one reason. They are both set up as what? Y. Y equals, yes? So I can do one of two things. I can take all of this here and plug it in for Y. Or I can take all of this here and plug it in for.
Oh, okay. I see.
Which one should we do?
This one.
Why not the other way?
I don't know. Because this one's easy.
Wait, if I do it either direction, what ends up happening?
Yeah, they're going to be on the same, different sides.
I mean, we get the same thing. It's just one way or the other. We do this here. Yep. Now we need to get everything on the same side. 2x and add 2. Because I believe that y'all have reached a point where we can do more than one thing at a time.
Yeah.
Hopefully. Mm-hmm. Well, hey, this thing does factor. Mm-hmm. Which one's positive? Which one's negative?
4 is negative.
Mm-hmm. And 1 is positive. So it means x plus 1 is equal to 0, or x minus 4 is?
Negative 1 and
Mm-hmm. And we had y is equal to 2x minus 2, yes? Okay. Now I'm sticking with this one here because the other one is a quadratic. It's going to be a little bit harder to work with. Because out of our two equations, we get y is equal to 2 times negative 1 minus 2. 2 times 4.
So, negative 4.
So this would be negative 1 comma negative 4.
6.
Yes. Would be our 2 points. So when we look at this last problem in the graphing calculator, we can type it in as x squared minus x minus 6, because that was our first equation. The other equation was 2x So we see it crosses in 2 points. Let's see what those points are. Second graph, if we look at the table. So we're trying to see what value of x. Well, negative 1, we have the same y value.
4.
And at 4, we have the same y value. So those are the 2 places it crosses, because at those 2 points, they have the same x and same y. So those are our points of intersection. Now, if we look at the first one, the one that we did before this had no solution. Now, I'm going to have to do a little bit of manipulation with this here to get it to work. Because if you remember, it was 2x squared plus 4y minus y squared. So to get this to work, we actually have to solve this for the value of y. To get y by itself, 2x squared plus 4x. Now, because we square rooted both sides, we also have to have negative square root of 2x squared plus 4x. So really, I got it because it was 2x squared plus 4x minus y squared. Move the y squared over and square rooted both sides. Because the graphing calculator here only really deals with y equals. If you're working with Desmos graphing calculator, the online calculator, you could type it in as 2x squared plus 4x minus y squared equals 0, and it'll work with it just fine. Now, the other one that we had was, we'll have to solve it, because it would 2x plus 3 And really, for our case in point, those really do intersect, they do cross. So it does work out for this here. But if we notice, these here do not cross or intersect at any point. So it doesn't work for us here. So that's why it's a no solution, because they do not intersect, they do not cross. And that's really what we're looking for. If we're talking about graphing or substitution or any of these here, we're looking for the point where the two graphs intersect or cross. And that's really what the graphical approach is we're looking at the graph to see where do they intersect, where do they cross, where is the x and y value the same. So you can have one intersection, we can have two, or none. And that's really what this one here is going to be. Y equals ln of x. From this one here, we can subtract x, and y equals negative x plus 1. Clear. Clear. Ln of x. And this one here was negative x plus 1. And if we graph this here, hey, they have one intersection, 0. It's at the point 1, 0, because that's where the values of y are the same. Now, there's not going to be any other values because the logarithmic function does not come back down. It's going to keep going that direction. So there's only one solution. So for some of these here, it might be easier to go on and just graph them than it will be to actually try to solve them by hand. And some of them will be decimal answers. Questions on this here? Yep. Solving and plugging in. And we can check it and see that, yes, they both work in two variables. Now we can talk about doing the same thing for break-even points. Where are two going to be the exact same? Where's my cost and my product, or cost and revenue, going to be the exact same? And we can look at this here because it's pretty much saying the total cost is cost per unit times number of units plus our initial cost. How much did we have to put in? Now, revenue equals the price per unit times the number of units. And if we use these two equations together, set them equal, we can see that the company must sell at least 5,455 units before they're going to start actually making money. That's their break even. Another way to look at it is profit is equal to revenue minus cost. How much revenue do I have to make before it starts being greater than the overall cost? But that's it.